So, what is binary search? Imagine you have a list of 1000 numbers, and you're looking for the number 1000 within it. One approach would be to search for your number from the beginning of the list until you find 1000. Now, you don't really know how long this will take given the list is in random order. But if the list is sorted, your worst case scenario would be to search the list from 1 all the way up to 1000, taking you exactly 1000 steps. This approach is known as linear search and has a time complexity of big O of n. But to give a clear picture of how worse things could get, let us imagine for a second an app like Twitter with over 300 million users, and you have to find a friend. Given the worst case that names are arranged in order and your friend's name starts with the letter Z, this search would take you well over 300 million steps. This can be very inconvenient, especially if your users expect instant results upon clicking search button. So instead, let's consider a new approach. Take the same 1000 numbers sorted in order from 1 to 1000. To find the number 1000, we first search the middle of the list, giving us the number 500. And then we check if the number we are looking for is less than or greater than 500. Since our number is greater than 500, we argue it is greater than the middle. So we get rid of the left half of the list and continue with the right half. We repeat the same procedure with the remaining half and get the number 750. And we continue with the divide and conquer approach until we reach the number 1000. This approach is known as binary search and would take us about 10 steps to find the number 1000 in a sorted list. The time complexity of the algorithm is big O of log n. And if you were to calculate the base 2 logarithm of 1000, you would arrive at approximately 10, a testament to the efficiency and power of binary search. So, in comparison, in the linear search, in the worst case, it took us 1000 steps to find our number. But in binary search, it actually just took us 10 steps. Okay, so now that we see that the binary search is effective, let's see how to implement it in code. For this, we will be using C#. We begin by creating a class. We're gonna name the class binary search. And inside this class, we're gonna create a function we will call binary search function. The function will take two parameters, a sorted array and a target of type integer. The function will retain an index. That's why it has the return type int. Inside this function, we create two variables. The first variable will be the left half variable. We're gonna initialize it to 0. And the second variable will be our right half variable. And we're gonna initialize it to the length of the array -1. Ergo, last index. And then we're gonna create a while statement. In the while statement, we're gonna put the condition that left half is less than or equals to right half. And while that is true, we're gonna loop through the array and splitting it in half as we go. Now inside the while loop, we're gonna create an index of the middle value. We will call this index mid. The index will be found by saying left half plus right half minus left half divided by 2. And this will give us the index of the middle value in our array. And then we're gonna make our first check. We're gonna check if the value in the middle is equals to our target. And if that's the case, then we just return the index of the middle value. Else, we're gonna check if the value in the middle is less than the target, meaning that the target lies far to the right. And if that's the case, then our new left half must start from the middle, effectively ignoring the lower part, or rather the left part of our array. Else, the middle value is greater than the target value, meaning that our target lies to the left of our sorted array. Then we will change the right half index into the middle and ignore the right part. So by ignoring the right part of our array, we will now focus on the left half of the sorted array. And so we will continue looping through these conditions up until we find the value that we're looking for. If we do not find the value that we're looking for, we're just going to return -1, indicating that we did not find our value. Let us test the function. So we create a sorted array and we create a target value. We're going to say it's 7, and then we're going to create a variable result where we will store the binary search function's return value. And then we're going to check the return value. If the return value is -1, then we just write the value was not found. But if the return value is anything other than -1, now that means that the value was found, and we're going to print the index at which the value was found. So now let us actually run the code. Now, as you can see, the code runs, and we are able to find that 7 is at index 3. I hope you liked the video. Please like and subscribe if you